asked you to factor these, and what's I don't know, hopefully you found something interesting about it. Guys, what we're going to talk about right now is related to the fundamental theorem of algebra. Sounds very important, doesn't it? Yeah. It's actually not very fundamental, but it is a big deal, I guess. The fundamental theorem of algebra says that if you have a polynomial equation or function, like this guy right here, whatever its degree is, that's how many roots there are. Roots are related to what? Do you guys know? They're related to solutions, or aka x-intercepts. So check this out. We factor this first one, and this first one is x plus 4 and x minus 2. Hey! We factor this next one. This next one is x plus 1 and x plus 1. Can I write it as x plus 1 squared? Yes, you can. Oops, I meant to write that in a different color. And this last one is not factorable. Okay, check it out. Now, roots, like I said, they're related to x-intercepts. So if we were to graph this guy, you can see what our two answers were right there. You guys remember it was x plus 4, x minus 2? Check it out. There's negative 4 and there's positive 2. All right. This one right here was x plus 1, x plus 1. Oh, look at this. Look at this x-intercept right here. Negative 1. And there's one x-intercept, but it had two factors right here that had the 1, right? It was x plus 1, x plus 1. And look at this last one. What's happening with this green one?
It's not on the x-axis.
Not even crossing the x-axis. So what does that say about our theorem? Is our theorem now not true? Nope, theorem is still true. The reason why is because we can solve this a different way. We can solve this using completing the square, or we can solve this using the quadratic formula, and then we would get the answer. Okay, so let's say this is equal 0. What is the answer? This is where fake numbers come in. You guys ready for fake numbers? Yes, not really, but I'm going to say yes. Okay, so what was that formula? I'm going to use the quadratic formula. The negative boy who couldn't decide whether or not he wanted to go to the radical party, so the square boy missed out on 4 awesome chicks and instead stayed up all night until 2 a.m. playing video games. So that's your B, that's your B, that's your A, that's your C, that's your A. Now if I simplify this, it's going to be negative 3 plus or minus, and that's going to be a 9 minus 12. And so that's a negative 3 inside there. Oh my goodness. And a 2. That's the problem, people. Can you take the square root of a negative? No. Not Doug. So check out what we got here. We can rewrite this as negative 3 plus or minus the square root of 1 times the square root of 3, which is slightly better, but not 100% better. And there we have someone famous. You guys see that square root of negative 1? He is famous. He is so famous and so important that he gets his own letter. He is negative 3i square root of 3. Now I like to write the I right here because I don't like writing him right here because then sometimes it looks like he's underneath the square root. But it's okay if you did. It's still correct. Now he's a complex number, guys. He's complex. Why? Because there's a fake part of him. If there's a fake part of you, you would also be considered complex.
Why did they make these?
Oh, because it's very important. It has to keep the fundamental theorem of algebra true. Now check this out. You can write this a different way, the standard way, and that would be negative 3 divided by 2 plus or minus rad 3 divided by 2. How'd you do that? I divided this by 2. I divided this by 2. That's how you get it. And don't forget your I. Now there's 2, right? There's the plus and there's the minus. There's 2 roots. Degree of 2. Fundamental theorem of algebra still stands. Oh my goodness. Okay, so the standard form of a complex number is a plus or minus bi. So in my complex number that I have right here on the screen, what is the a? Look at it. Negative 3 over 2. And what's the b? So this complex standard form has 2 parts to it. It has the imaginary part and the real part. Which one is imaginary? Is the negative 3 over 2 or the rad 3 over 2 the imaginary part? Rad 3 over 2 is the imaginary part. How'd you even know? Well, because it's right next to the I. And then this one's the real part. So we got imaginary part, real part. There's your intro, guys. That's a complex number. But I can't stop talking about the I until I do a couple more things. What does I equal? Does it simplify to anything? I is the square root of -1, which doesn't simplify to anything, so I'm just going to leave it. Oh, what about I squared? That is the square root of -1 squared. So what does that equal? -1. And then we have I to the third. I'm going to kind of manipulate this, dog. I'm going to write I to the second times I to the first. Am I allowed to do that?
Yes.
I mean, because like you would just add the exponents if you multiply these i's, correct? And what is I squared?
-1.
-1. And then we're multiplying it times I to the first, which is the same as this side, which is just I. So we get -I. Whoa. What is I to the fourth power? Now things are getting crazy. I could write this as I to the second power times I to the second power. And what is I to the second power?
1 or -1.
-1. Right? I to the second is -1. So we go -1 times -1. What do we get? Uno. Oh my goodness. Okay, so what about I to the fifth? Well, I to the fifth.
It's 1.
What is that?
1 times I.
Well, there, if I follow your logic, I can go I to the fourth times I to the first. And what is I to the fourth, my neophytes?
1.
Uno. What is uno times 1 or I? Just I. Wait, what? I? We're back to the I? Yes. What is I to the sixth power going to be?
-1.
I to the fourth times I to the second power. I to the fourth is uno. I to the second is -1. And so what is 1 times -1? Did you say you to the uno?
No, when I say ew, I mean I love it.
Oh, okay. All right, so are you guys getting used to the pattern here? Do you guys know what I to the seventh is?
Yes.
What is it? It is -I. So what is I to the eighth?
1.
Uno. So you guys are getting it. Yeah? Okay, so what is I to the 20th power? I'm not going to talk now. You guys get time to think. Go. So your answer is? Uno. Okay, there are tricks, guys. Now, if your exponent is divisible by 4, then you can write a bunch of I to the fourths, and you would get uno. If it wasn't divisible by 4, like let's say it's I to the 30th. It is an even exponent, which does tell you something. You can split it up with I to the second powers. Now, is this divisible by 4?
No.
Not, Doug. It is not. 28 is divisible by 4. So if I go I to the 28, we know that this right here is uno. And then we have I to the second. What is I to the second?
-1.
-1. So we'll go times -1. And we get our final answer as -1. Hopefully you guys can find the other tricks by using your cabezas.